Sir, you may please turn on your camera.
Okay, okay, okay. Content introduction here. AOD retrieval data types, method, impact, climate and health recommendation for improving AOD retrieval accuracy, and then conclusion. In introduction part, aerosol are a crucial component of Earth atmosphere. AOD measure concentration of aerosol in vertical column of the atmosphere, which is for vital understanding for influence of radiative forcing and climate change. In Jaipur, provide a unique context for a study aerosol dynamics due to its rapid urbanization, frequent dust event, and significant vehicle and industrial emission. The city aerosol regime is influenced by variety of sources, including local and regional dust storms, which are affect visibility and air quality. Understanding the aerosol load in Jaipur is crucial for effective air quality management and public health protections. This is a formula, empirical equation for aerosol optical depth analysis. And then interaction of aerosol with the lithosphere, atmosphere, hydrosphere, and biosphere. There is a interconnecting between aerosol and various other component: atmosphere, hydrosphere, biosphere, and lithosphere. I am I done various review of literature. Wang and Christopher they use a PM 2.5 and aerosol optical thickness using modest data. In this various I am finding there are key findings in which AOD data for pre-monsoon, monsoon, post-monsoon, and winter. In pre-monsoon, AOD values are due to dust storm for the Thar Desert. Monsoon reduces AOD because rainfall with minor contribution from biomass burning and traffic. Post monsoon AOD increase due to agriculture residue burning and industrial emission. Winter persistent high AOD causes by biomass burning, low atmospheric boundary layer and emission from heat sources. There are there are various data types which are used for AOD retrieval. Data types visibility data, temperature, humidity, wind speed and direction, aerosol, models, surface reflectance, and topography. There is various roles of these. Temperature, high humidity causes aerosol to grow in size, leading to residue
You can continue with your presentation. There's no issue. There's no issue in not opening your camera. So you can continue with your presentation.
These are the some arrows presents over seasonal variation. So source attribution, impact on climate and health, challenge in AOD retrieval using visibility data. Some recommendations incorporate multi-source data integration, refine empirical method models, adopt advanced machine learning techniques, improve data quality and resolutions, address seasonal and diurnal variability, enhance atmospheric correction technique, conduct comprehensive sensitivity evaluation, leverage technological innovation, long-term monitoring, and trend analysis. There is conclusion. Uh, in conclusion, AOD retrieval data complex regime methodology and challenges of retrieving aerosol optical depth using visibility data. Study rapid urbanization and industrialization regions like Jaipur. Potential of visibility data method approach of AOD or retrieval in source or constrained settings, methodology refinement and technological advancements or decision making and environmental management, climate policy, public health protection, and then particularly in rapidly developing urban center like Jaipur. Thank you.
So now we are open up for questions. Audience, you may ask questions.
Any questions from the audience side? There's one question, I think.
Sir, am I audible? Sir, am I audible?
Yeah.
Yes, sir. Sir, in the presentation you just presented, there's a certain term you used as aerosol. Sir, what was that and how is it used in civil engineering? Can you please explain that?
So voice not clear. Please repeat.
Uh, am I audible now? Hello? Am I audible?
Sir, voice blur over.
Actually, we have first year UG students who have asked a question about aerosol and its applications in civil engineering practices. So, can you explain it a bit?
Aerosol is environmental side, civil engineering. Hello. Hello.
Yeah, you may answer.
Sir, I didn't understand what is the.
We have first year UG students in the audience and they have asked a question. What is aerosol
Yeah.
and applications of aerosol in civil engineering? So,
Okay.
yeah.
Civil engineering consider environmental science. There is a branch of environmental science in civil engineering in which aerosol particles are used to calculate air quality indexes. In today world, we are all know about the air quality indexes. In air quality indexes, we use aerosol, CO2, NO2, and various other components of air pollution. Okay.
Yes, sir. Okay.
Any more questions from the
Any
audience
more
side?
questions?
There is one more question.
Hello, sir. Sir, as you mentioned a term diurnal variability, what is it?
Yeah.
Sir, as you mentioned a term diurnal variability in your recommendation, what is it, sir? Can you explain?
Diurnal.
Variability, diurnal variability.
Uh, there is a change in the temperature and the seasonal variations are there. There is a mostly two changes, summer and winter. Okay. Hello.
Yeah, so he got his answer. Any more questions?
Okay, thank you, Mr. Raman Yadav, for your wonderful presentation, and thank you for your contribution in the conference. Okay, thank you so much.
Thank you, sir.
Now, moving on further, we are now privileged to invite Dr. Arya Sadi Langrodi to present on the topic Nature-Inspired Solutions for Urban Ground Improvement. I would like to share that Dr. Langrodi is an associate professor in geotechnical engineering at UEL and chair of the Nature-Inspired Solutions for the Built Environment Initiative. He specializes in soil micromechanics, urban ground improvement, and geohazard mitigation. Sir, please grace us with your insightful thoughts on the topic.
Thank you. Let me share my screen. And can you hear me clearly?
Yes, sir, you are
I hope that excellent. Thank you very much. So, good afternoon, and thank you very much for having me. It is an honor. It is a pleasure to have this time to talk about some new aspect in geomechanical design that I'm working on, and probably that can initiate some insights and hopefully some collaborations in future. So thank you for very much for the chairperson and all the organizers of this amazing conference, the International Conference on Research and Innovation for Sustainability in Civil Engineering. I'm Arya Langrodi. I'm from the University of East London, and I will be talking about biomimicry in geomechanics. I will talk about the philosophy of biomimicry, but I will bring that into the context of soil stabilization. I will start with some very simple definitions. How nature is defined, and what do we mean by nature-inspired design, or biomimicry, or biomimetic design? You see, we are all doing this, but we are unaware of that philosophical background of what we are actually doing. That's why it's important to start from these definitions. And then I will talk about some ideal geotechnical functions of soil. And I move forward and talking about ideal geo-environmental functions of soil, because what we often forget is that soil is a material that we want to change, we want to transit it into an engineering material, and we overlook all other functions that soil can have, all other ecological and hydrogeological functions that soil can have, and they may get compromised on that transition. So I will talk about these functions. And then to bring the biomimetics and biomimicry into that kind of arena that we all understand, I will start with a benchmark geotechnical problem. A very simple problem, a loose silt that we want to stabilize, but not by densification, but by loosening it. So a loose silt that becomes looser but gets stabilized. And in designing this technology, I will again talk about the biomimicry. I will talk about that natural biological system that we tend to get inspired from, and then how we do the design and how we measure the response of that design in a very, very simple way using simple testing techniques. So let's start with nature. Nature can be, and for an entity to be nature, it needs to have two principal, if you like, characters. It needs to be able to self-produce, and that is something that we know that it happens in biotic materials. But how about abiotic materials? A few years back, we looked into crushing of quartz sand, and we realized that there are certain sand and silt sizes that get crushed, but then they regroup and if you like, weld, and they create certain other sizes that are bigger and they are predominant in nature. And we call these sizes favored sizes because we can find a whole lot of them in nature. And that brought this idea that even abiotic entities can be self-producing, can be self-constructing, and hence they can be branded as a natural material. Now, moving away from self-production, the second character of an entity to be nature, of an entity for us to get inspired from, is self-delimiting. It needs to have a limit for human being that can be skin. For soil, that limit is interparticle forces, another area of my interest. Interparticle forces keeps the particles separate from one another, convey the forces and the stresses along the chains of particles, and at the same time give you that integrity. So the limit in soil as a abiotic natural entity is your interparticle forces. So now we understand what can be branded as nature. And it's important because if something is natural, then we are allowed to learn from it and reflect on that learning and bring that into engineering design, in our case, geotechnical design. There are four things that we can imitate. The matter, the material that is creating that natural entity. The form. Now, the structure is something that we all understand. Microfabric, microstructure, but also organization. So let's say in soil you have particles, and these particles group together to create, if you like, domains, clusters. Now, the way that these clusters sit next to one another, that is organization. Function. This is quite interesting. Every natural entity should offer a function, and we are interested in these functions because some of these functions might be useful to us when we are doing ground engineering design. And then generative procedures. A natural entity should follow procedures to regenerate itself. These are the four traits for a natural entity that we are trying to imitate and create our biomimetic inspired design or nature inspired design. The philosophy was written in a very geotechnical, if you like, terms in this paper, and it was very generously published in International Journal of Geosynthetics and Ground Engineering, for which I'm always grateful to the editorial board and the editor-in-chief. Now let's start with our benchmark problem. So we are having a loose silt. It can be a low-sick material, it can be a collapsible material, so it's subjected to excessive deformations under loading, wetting, or a combination of both. It's problematic. It has a packing state, and it has a very high void ratio, let's say 0.91. The entire densification strategies that we are following, even those that are quite sustainable, we use sustainable materials to fill these voids, are revolving around densification. We are decreasing the void spaces, we are either filling the void spaces or densifying these void spaces, and that improves the soil mechanical properties. But what we are not really paying attention to is that these pore spaces are also an arena for flora and fauna and microorganisms to continue thriving and living. So what happens if we decide to strengthen this very open-packed silty soil by keeping the natural pores, if you like, network intact, or even by further loosening it to help all other functions of soil to thrive? So the way forward is biomimetic. We are taking nature as model. So we need to find a natural thing to imitate. And that natural thing, in this example, can be fungi. Fungi colonizing soil. Why? This is quite interesting because fungi is made up of mycelium, and mycelium, which is the mother of fungi, creates spores around rootlets, which happens to appear in soil, happen to exist in soil, and then these spores open up and expand within the soil medium and basically colonize. What they do is that they exude a very sticky material, and that gives cohesion to this base soil material and groups the soil particles together into these domains. And it also exudes a network of hyphals. These are like microfibers, nanofibers, and these fibers go inside these pore spaces and these domains and tie them together, pretty much like fiber-reinforced soil. So the system is quite interesting because as these hyphal networks grow into the body of the soil, they also depart these domains of soil particles from one another. In a way, they arguably increase the airborne content or the vote ratio of the soil. So it's an interesting material, and we probably can get inspired from this natural entity to design our technology. How? So let's start with matter. The matter is rootlets. We may think about a fibrous organic material like press nut, or that's waste that comes from sucrose refining in sugar industry. We have a certain sticky material that can be a geopolymer, a biopolymer. So let's think about another waste of sugar refinery, and that is a calcareous waste. It is again known as press mud ores, or so this is the fibers, you know it more as bagasse. This is the press mud. So this press mud is not really active, but if you activate it with an alkali, and that alkali itself can come from crop residue, then yes, you can get these sticky residues. The fibers that are the remnant of fibrous material inside your press mud waste, and the soil, which is the siliceous stuff, and that's your base soil that you already have. What else? Forms. So in terms of forms, you have groups of spores, and these are pretty much spherical. Now, these can be your crystals, these can be your ferric oxide. Now, interestingly, 28% of press mud is made up of ferric oxide. And in early times, when you are not given time to the material to polymerize, for these polymers and cementing agents to form, your reliance on of strength, your strength is